Absolutely. So now it's recording. And again, just a quick recap. Obviously, Mindcore, Dispersive, and TAMA are conducting this meeting among us to showcase the private network connectivity between the TAMA enclave and Dispersive cloud, going back to the customer on-prem environment. This is a strategic integration for our partners and service providers like Mindcore to be able to position the secure network architecture that we integrated to customers, such as some of the opportunities that are in the works right now. We were just talking about, what are the core value propositions of this integration, and really support some of the conversations that all of us are having, whether it's with prospective customers, also existing customers on TAMA side, for whatever that worth. So I wanted to start with that because obviously it's important to, talk to the customer, what is the difference between having this integration in the TAMA enclave or having this type of connectivity from the TAMA enclave to your on-prem environment or even cloud workloads, as opposed to doing something like traditional VPN configuration. Just gonna do some name dropping, like using Zscaler or Cloudflare or something else. Or also, what's the difference between this and doing also an IPsec tunnel that's going through the internet? So the biggest difference is obviously with traditional VPN technologies, as well as protocols like IPsec, you're still negotiating traffic over the public internet. You still need to punch holes in your firewall and in your LAN interface in order to communicate to the workloads between the TAMA enclave and the workloads for the customer. So what you look at here on this slide is really the core value propositions that we can position to the hospital and additional customers as well. So you could see there zero exposure connectivity. It is a full private link between the enclave and the customer workloads. And for Colin, Marcos, everybody, the way Tiani and I did this and deployed it is really, we're actually not doing any IPsec tunnel under any capacity for the enclave. The enclave itself is still locked down to the world. We're actually using our gateway that is part of the enclave, that's part of the TAMA router, and we're configuring a route from the router only to the dispersive DVM gateway, which would be sitting on the customer side. You're still not doing any IPsec tunnel negotiation. That will still need to punch another hole, and you need to open your firewall to communicate on the tunnel to the workloads. So complete private, and we're actually hitting a private endpoint. We'll show you what that looks like as well in production shortly. But it's full overlay, private overlay network, no public internet, no IPsec tunnel, no obviously VPN configurations. This in return obviously will enhance security, goes without saying. Full encryption over the tunnel. The customer at that point would also be able to leverage all the posture controls that are provided by the DVN or the dispersive stealth, right? Because you're using the dispersive cloud to communicate to these assets and the systems that they're going to be accessing. So that includes, and Tiani, you can chime in, but it would include multi-channel communication, increase the throughput, which obviously would help with the user experience as well, but also the ability to diverse traffic if something was to go down or if there's an incident or a compromise on any of those channels.
So, and we're really highly resilient architecture too. So in case of DDoS attacks, replay attacks, in case anybody, and just like AWS went down because of a DNS issue, a lot of AWS customers suffered. We did not, even though we were built on AWS at this current point in time with the corporate cloud that we have. We did not go down because all of our stuff does not rely on DNS. So that's why we're highly resilient. We keep the lights on even when other clouds are going down, and that's additional benefits, right, for going with this person. So
absolutely. Simplified architecture, also another important point. When you're doing traditional IPsec or VPN, you still need a gateway that is sitting on the customer side. Obviously, a gateway is still going to be needed in the case of dispersive and going through the dispersive cloud, but you're not deploying an additional endpoint in the TAMA enclave and use that as your termination point to the customer workloads. It is all in one as part of our stack and deployment. So that's what really we spend time on, is really how to simplify it, yet still ensure that it meets high security standards. Literally no additional configuration is required from the customer perspective. What I mean by that, and again, we'll get into the how momentarily, but when we're building the enclave, our router is simply getting configured to the dispersive cloud and the private endpoint that we're after. So no tunneling, no IKE version 2, no PSKs to deal with, rekey, reauth, all that good stuff. So really simplifies that. And obviously we spend time working on integration report and doing sessions with Tiani and the dispersive team and the Tama team from my side as well. But the entire deployment, really, when you look at it, I mean, an hour, with no exaggeration, if we've got all the ducks in a row, an hour, everything can be connected together between the enclave and the remote site. So it is really simplified, and in return, that takes us to the fourth point, operational efficiency. So actually talks about under an hour per enclave with minimal manual configuration. From a compliance perspective, obviously we're a cybersecurity platform. Dispersive Networks is network security solution. So this meets stringent compliance requirements, especially for things like securing EPHI, HIPAA, high trust. You could see other assertions on there like CMMC level 2, NIST, etc. So again, you are going through a private network to the private endpoint. You're only allowing access to whatever we're going to put through the route table. And if you have an SQL or database that is hosting or going to maybe an application, so it could be an app data server that is hosting personal health records or anything of that nature that needs to meet compliance, this is the solution that would allow you to meet these type of controls. Yes, ma'am.
Okay, so I'm told that there's no other solution on the market right now when you combine Tehama and dispersive, what we're talking about here.
Absolutely.
That solves these problems.
Correct.
Can you explain exactly why that's true so that I can tell prospects, truthfully, there is nothing else on the market like this? It's going to be at least 2 years before somebody catches up with us.
Absolutely. The solutions that you would need to look at, you have to look at the competitive landscape, of course, and I'm sure that's exactly your thoughts, and the customers you talk to, that's probably our thoughts as well. So when you look at the competitive landscape, you need to look into two different distinct type of solutions to provide what we're providing to the customer under a better together one unified solution. You have to break that either under the network security / gateway type of solutions or offerings, as well as secure data enclaves or secure workspace offering. So if you look into the secure network type of products that are out there, you need to look at things like firewall as a service. And so some of the names that maybe customers would ask you how this stack against Juniper products, Juniper SRX products, Cisco gateways, Zscaler, right? Even CrowdStrike, although it's more on the posture check type of element as opposed to access to workloads. But when you look at these solutions, you're only really tackling a small piece of the environment that's needed for secure access to mission critical data and applications. You then need to acquire additional type of solutions to grant that type of access. For example, you need to have a Juniper SRX. You need to bring a DLP solution. You need then to bring in something to allow and route access, like a VPN, like Zscalers of the world. And then, not to mention, and we don't care about the VDI, as you know, in the conversations we've had, but you still need to have something to allow the interaction and access to the resources that you secured and governed and made sure it's compliant. So it really, Matt, it goes back to that consolidation of stacks and the fact that you need to acquire different solutions and different capabilities that are out there to get close what we're providing in here through Mindcore completely out of the box.
So I'm a skeptical prospect. And so as a skeptical prospect, I'm going to say to you, well, that doesn't make sense. You got Juniper, you got Citrix, you got all these major companies. How is it that two little startups are the ones that figured this out and nobody else is even bothering? Maybe it's really not that important. Maybe it sounds great, but if it was that big of a deal, other people will be doing it, and why isn't anybody else doing it?
Well, those organizations, I would say, and maybe I defer a bit out to Jason and Mick on this, but my perspective on that, Matt, is that these organizations really don't care about the total cost of ownership. And that's what really, I think, what really comes down to. They have figured it out in a sense where you need to acquire something else and integrate it with these solutions in order to provide what we're providing out of the box. It is not part of their focus or discipline or type of offering to provide a complete secure workspace, right? I mean, we're talking about the network security element by itself, but you're still missing the other pieces of the puzzle that you need to put together to get to what we're getting that is, again, complete and provided out of the box with minimal effort and no overhead whatsoever. Jason, would you say this is the right?
Wait, let me ask you a question. Hold on. Let me ask you a question. I'm doing this for a reason, because when we translate this and we get the transcript, this is my marketing material.
For sure.
And this is exactly what this spot right here is what people need to understand that we're speaking to, who are looking at moving off of name brand major products. And what we're doing is showing them something that sounds way too good to be true. And most people think if it's too good to be true, it probably is. And I'm trying to have you explain why it's not. So what I just heard is a really good answer, which is, I was like, I have to lift the weights while I'm talking to you. The answer is, I think what you just said is, they're so big and they're making so much money off of this. They don't want a solution like this to be put out there, and they're not going to compete with themselves and give them, put something out there that's cheaper, better, more streamlined, all that. Right? They don't want it.
No.
So we found a very specific niche, which is streamline everything, simplify it, consolidate it, and in the process, save a lot of money.
Secure.
Yeah.
Don't forget secure. Yep.
Secure. Yeah. And so they don't want to solve that problem. In fact, they don't want us to solve that problem.
No.
And so Mick and Jason, if what I just said is correct, and Mick, for me, you, Caleb, that is like the crux of our conversation, is it not?
Absolutely. And your proof point, then they'll turn around and say, well, hold on a sec, your infrastructure, why is it, best thing since sliced bread? Well, hey, this didn't happen by accident. The origins of this technology is in the defense arena, and this is the nature of the solution they're looking for. All we're doing is now leveraging it in the commercial world. Hey, on the other end of the solution, yes, the typical enterprise ISV out there is looking for a range of technologies, and they're all making a ton of money of it. None of them have an interest in reducing all that complexity down to one integrated platform with a data enclave, right? And another characteristic is VDI is increasingly commoditized, if not already.
Yes.
Your true value is not the VDI, because if we had more money, we'd be integrating another VDI in here. If we had more resources, I'm sure, I don't want to talk on behalf of Tiama. So take the VDI out of the loop. It's really the simplification of compliance and governance, where today you need 20 and 30 products.
So what we've done, Nick, is we've innovated. We saw a space, we innovated. We created something that nobody else is really looking at. And okay, so this makes total sense. And from my guys, this is the marketing, this is the conversation when we're on the phone calls and people are giving us this sort of pushback. It's like, this is really simple.
Yeah. Hey, Matt, just to cut you off a little bit, Tiani, and maybe you can share the observations out of the guys we were talking to in Europe during the past week. I remember one comment from them was they were blown away by the nature of the solution, how simple it is and comprehensive. And they made the comment, I may be using it incorrectly here, this is how TCP/IP was supposed to work. I don't understand fully the implications of that. Maybe Tiani and Modi can expand on that, right? But it's just another proof point. That's all.
Tony, can you elaborate a bit on that? Because that's really interesting, what Mick just said.
Yeah, so I think it's just the security implications, right? The internet was not designed with security in mind, and so everything that you do on the internet, it's basically like a public, right? Everyone can see what you're doing. So what we've done is take the public internet, right? That was supposed to be secure, like TCP/IP was supposed to be secure, and added that security that the founders of the internet didn't put in at the time. And so for right now, that was their comment, is that we've added a very simple way and a very effective way to essentially provide that security for you over the public internet, right? Where the founders of the internet were supposed to add that, right? And they weren't able to. So, and that's what they were saying, is that it's so simple and so secure that it almost feels like, why didn't anyone think of this before?
Yeah.
So, and that was the comment.
That's awesome, Tiani. And just for Matt, Colin, and Marcos and the team at Mindcore, from that, what Tiani just explained as far as the network obfuscation, that everything is secure, everything is private, everything is protected. Now you're taking it all the way to where hands are touching the keys for the end users, and you're providing them a secure workspace with DLP, endpoint isolation, and the ability to interact and audit and govern the workloads, right? So it's like you're closing your windows, doors, locking everything, and also putting an extra security protector on top of it. Does that make sense, Matt?
It makes sense. The reason I was asking the questions is because I have it now. I needed one cohesive, straightforward, like competitive advantage that I could turn into marketing.
Mhm.
And I needed to hear you guys say all that, because that's really the answer to everything, and makes my life easier. Thank you.
Yeah, absolutely. Absolutely. So like some of the stuff we already talked about, and like I'll send this to everybody, of course, but I just this is just an overview. Next generation connectivity for regulated environment. What we've done is taking the DVN, the dispersive virtual network, through the dispersive cloud, and ensure access from the Tahama enclave through a private link to the customer workloads, on-prem, cloud, or hybrid workloads as well. The value propositions, we talked about that. The overview, you can see the enclave, the specific powered gateway deployed. So Colin, Marcos specifically, right, how it works. We deploy the Tahama enclave. And by the way, this applies AWS or Azure. We know at least Baton Rouge is most likely going to be Azure. But we deploy the enclave. This is going to do all the stuff that we do: resource group, VPC, elastic container, everything is deployed on there. The router, the router which sits in our infrastructure, can be also deployed in the customer infrastructure if desired. This is where now it is powered fully by the dispersive cloud. What we do is we go to the router, we make sure its ENI network is pointing to the dispersive gateway instance, which we deploy that as well. And then from there, we work with we configure the route table on the workspace subnet, which is where the desktop is going to reside, or desktops are going to reside, and we point it to the private link or multiple private links, and depending on how many workloads they have, right? So that's going to be that fully compliant, secure infrastructure that's going to be communicating back to the remote sites. And the customer environment, this is where the dispersive gateway appliance is going to be running it, right? So this is where they're going to have it at the hospital, and it is what's going to allow us to connect to all the workloads that are hosted on there. So that's simplified architecture. Steps to deployment, it's exactly what I just explained. Do our enclave with the gateway, deploy the customer side gateway with dispersive, establish a secure overlay, and the secure overlay is really us pointing again to the private link, and that gateway would then be registered with the dispersive cloud, where you'll be able to actually see traffic going in. And Tiani has a pretty cool GUI that he's going to show us as well, just as I'm actually going to connect to the private endpoint. And then from there, you can validate and monitor. And that includes, obviously, our analytics, as we just did our training with the Mindcore team, through desktop intelligence and automation and what that entails. And also from a network communication perspective, you'll also get those analytics from the dispersive cloud console, which is obviously instrumental for the customers. I'm not going to spend too much time on this, but just so you know, we actually got it all the way to a point. Again, this is high level, and we've got the full-on joint operational responsibility. This is important when the time comes, whether it's December or January, we get into a POC. This would be part of the statement of work, so the customer knows what we're doing on the enclave, what is going to be on the infrastructure side, but most importantly, what is actually going to be on their end. So they know what needs to be set up, and what endpoints we need to communicate to, and what is the level of effort and the personas and stakeholders that are going to be involved in these conversations. So that's kind of the ROSI element to it. Oops, wrong direction. Security and obfuscation layer, multi-path encryption, private overlay network, anti-jamming protection, compliance framework. So this is taking everything that Dispersive does and what we do as well, And I'm sorry, my headset is
Odie,
dying
when you're
on me.
ready, I want to ask another question.
Yeah, just give me a second. My
Yep,
headset
just let me know.
is dying. I'm gonna flip to mic and this. Can you still hear me? Okay.
Yes, we can hear you.
Okay, talk now.
Yo,
I can.
you hear us?
Yeah, I can hear you now.
Can you hear us?
Yes. Can you hear me?
Yep.
All right.
Yeah, you're
Perfect.
good.
Yeah. What was your? Sorry, Matt. What was your question?
So the hospitals we're speaking to, just in case somebody turns around and says, well, this all sounds great, but we're HIPAA compliant. We had an audit, we passed it, we're good. Yeah, things aren't centralized, they're not streamlined, but why do we need all this stuff? Like, we're good now. Why do we need this? Aside from that, okay, maybe it'll save us money, but let's say it doesn't. Let's say it's a break even. Why would we switch what we're doing now to move to this?
I would say my 2 cents, and then maybe.
And by this, but Modi, I mean the whole solution.
Yeah.
and dispersive, the whole solution.
The whole solution. Yes. I'll tell you what. I if that was positioned to me, Matt, I would approach it from a flood perspective. Sure, you passed your audit, but the threat landscape has evolved. I can tell you, and I tell you this because people can relate to things that they've been exposed to. Here in Canada, in Ontario, specifically where I am, in my province, over the last year, there has been over 100 cyber attacks to hospitals and healthcare organizations in the province. In my town and the nearby region, 5 major hospitals were hit by a ransomware attack that crippled our ability to provide healthcare services and patient care for almost a year.
Is this true?
Myself, my
That's a true story. They were taking notes on paper.
Is that Paul?
My dad went to the hospital and everything, everything, pen and paper.
Oh wow.
Okay, so that's true. Do you guys happen to have those stats? Marcos and Colin, just note down that I need to get as many stats as I can for our marketing.
Yeah.
Those are good stats.
We could probably find them. I mean, we could put numbers on them. Absolutely.
Okay.
And just like, you don't know the province, but Sarnia, London, Chatham, Windsor, those are major cities with over 200,000 population, right? It hit them all the way, and almost a year, everything is on pen and paper.
So you're saying to me, as the CIO of this hospital, okay, you're telling me that I'm not seeing the bigger picture, because even though I think that we're good, and this might not save us money, things are changing so fast that you're telling me that what I have isn't able to keep up with it, but this solution is?
Absolutely. And you
Tell me why.
You mentioned this in one of your latest videos on LinkedIn, right? So even though you had passed your audit, you're still not maintaining high security posture without having a complete secure workspace solution. And that secure workspace solution is not just data protection. It's not just identity and access management. It's not just password and secret protection. It goes from hands-on keys and the users, not to mention inside threat actors, but the moment the user's interacting with the data implications, all the way to how you're negotiating cloud traffic to gain access to these workloads for remote and hybrid teams and even on-premise.
Thank you, Modi. Very good answer. I needed
So
to
you
get that
passed the
documented.
audit.
Thank you.
You passed the audit, but that is your security posture doesn't necessarily mean that it is high security posture, because if there is a 0 day that comes out tomorrow, pardon my language, you're screwed. I was going to say another word, but you're screwed.
And with this solution, it's not your typical solution. This would account for that because of the way the entire thing works, and because these big companies don't seem to care about that, and they make money off of the breaches. This solution stands out.
What Tiani and Mick told me this, Tiani, the right sentence: if you can't see it, you can't infect it. Is it something along those lines?
Yeah, basically. So if you don't know what attack surface you're trying to hit, how do you aim for it?
Right.
You know, so
I think Matt, a good word to use is future proofing. That's what you're doing.
Future-proofing.
You are future proofing. Yep, 100%.
Yep.
Yeah.
Yep.
Yeah. And that's the 0-day element, right? So if something comes out right this second and nobody has a patch for it, you don't need to worry about anything. But again, passing your EPHI or HIPAA, it's not going to protect you from something that's going to come out today.
Okay. I know this isn't the point of the call, but I have you all in one spot.
No,
So
this is
I needed these answers for my marketing.
no, this is good. This is
Okay.
perfect. But yeah, so I think this is the end. Oh, there's one more slide. Let me check. Less than 1 hour of deployment, 2 gateway instances, 100% private traffic, simply put. Comprehensive business outcomes, private transport, rapid deployment, real-time visibility, seamless integration, compliance rate. And this is just business. So like, this is something, again, I'll send this so Matt and team, you guys could use that as well. But, kind of what's the threat? What is the problem that we're trying to fix in the market by having this solution? And what are the results for the enterprise? So that's kind of like a final overview picture. So wanted to show you how it actually works. So Colin and Marcos, Matt, no offense, obviously, just for the guys that interact with the systems. Do you want us to show you like how it actually got configured? Like I can go on AWS and show you that, or do you want us to actually get into a private to the customer workload? So I'll tell you, we connected the router to a private link, which is on-prem dispersive gateway that's sitting in Tiani's home, which can be any customer physical on-prem environment. And I'm able to connect to it through, after doing the NAT and after doing the route table, I'm able to connect to it from a Tahama desktop. So we have time to show you anything. So do you want to see everything?
Yeah, I would like to see the I know you're just doing it, you're basically doing the route table where you're routing out, like, I guess, internet traffic through to that VGW, essentially, like dispersive, the DVN. But I'd like to see that.
Yeah, so let me show. And this, Colin and Marcus, works the same on Azure. Some difference. Yeah. And instead of acquiring the dispersive AMI from the marketplace, we get it as a VM from the Azure marketplace, right? So route table, we call it for the workspace subnet, we call it in Tahama as a service in AWS, which I'll show you momentarily. In Azure, we call it desktop subnet. But same workflow, same configuration, same connectivity, right? So step one, we acquired the dispersive AMI gateway from the AWS marketplace. When we know where the customer is going to be deploying this from a Tahama perspective, let's just take Louisiana as an example, probably will still be US East. We would acquire it in that, and whatever account we're going to deploy their enclave is, this is all Tahama, so we take care of that. Then we launch that and deploy it on an EC2 instance. Azure would be a VM. The size is T3 medium. This also has its own, obviously, ENI. So if we get, before that, we did the security group, rightfully so, right? So we're only allowing in through 22 for SSH access. So that's
open to the world.
This is open on everything on port 2022. But we can, so Tiani, keep me honest, we don't necessarily need everything open to the world. We can still lock it down further, right?
Yeah, you can lock it down to only one IP address, and that's fine. And that's your management address, and that's the only machine that can get in. Everything else can be completely blocked. So
yeah,
okay, yeah, because we wouldn't want that open up to the entire internet like that.
Yeah, absolutely. So it's demo environment, right? But we can lock it down as much as needed. And then from there, what we've done is you'll actually see that it has its own ENI, so it's got its own interface ID. So this is already deployed. Like we deployed this first. Then we have an enclave in Tahama, and the enclave that we did the work on is this internal organization of ours. It is this finance enclave, and you could see in here, like these. Don't worry about these IPsec tunnels. We're not talking to those. So those, just pretend there are no tunnels in here. From this enclave, you could see. Oh, actually, you can't see that part.
You can see the subnet's the same as the AWS one.
The AWS one, exactly. And the other thing you'll see in here is the room ID, I just want to show you that this is the server. We talked about that, as you know, right? 1368. So what we've done in the AWS world, and maybe I'll bring this in here so it'll be easier to share everything in the same window. In the AWS world, what we've done is went to subnets, no tunnel. We go to the subnet for this specific enclave, and we added the private endpoint where the workloads are at and hooked it up to the dispersive ENI. So if I do actually just the room ID, you can see, and by the way, we only need to do it in one of the, this is just part of our architecture. We've got 2 workspace subnets, but we only add it to one and it replicates to the other one. So both have it. And if we go in here, you'll see if my route table, the private, in this case, the workloads at the hospitals, AKA Tiani's home right now, is sitting on 10, 100, 100/32, single, right? But it can be multiple, and it can be a larger range as well. You could see in here what we targeted is the ENI for the dispersive gateway, the one ending FFB. That's all to it. Because now this room from the workspace subnet, the desktops, workspaces that are inside of this subnet, which would be any desktops published inside of that room, will communicate to the traffic through the dispersive gateway, pointing to the workloads that we published in the route table.
So in reality, that dispersive gateway can sit anywhere in the world. It doesn't have to be. It doesn't even have to be at the client's location. It can be anywhere.
It could be anywhere, but this would need to be in their location. Tiani, correct? The 10/100.
The gateway on the customer premise needs to be there, but the gateway that Tehama talks to can be anywhere in the world. So,
Correct.
Yeah, as long as there's like a VPC connection to it. Either you do a connection to VPC or you set up somehow. You have to have a route to that, that instance.
Yeah.
Interesting that you're doing a route through the instance. I never did that. I usually do like a VGW.
Yeah. Well, so what we actually started with, we did a tunnel. We did the tunnel between ours and then the dispersive gateway. But it diffuses the purpose of what we're trying to do. We want traffic to be private and not going over the public internet. If we're doing a tunnel, you're still doing it. So what Tiani and I done first is we actually deployed the dispersive gateway in the same, which you saw, the same subnet. But then we did a site-to-site between our router and the dispersive gateway, but it has no way to communicate to the workloads that are elsewhere. It's going in a loop. So then we sat down and we were like, you know what? If we configure our workspace subnet for the router to speak to the dispersive gateway, publish the private endpoints based on the destinations, that will do it. And it really simplified for the customer. They don't need to touch any tunnels.
Yeah, very interesting, honestly. Like,
Yeah.
you're going through all the deflects, so it's never hitting the public.
No.
It like technically does because it has to get out, but it's never really publicly routed whatsoever.
Right, absolutely. And you may
those deflects and then it goes to the gateway.
Right. So that's another thing, is how much do they want to lock it down? And I don't know if you know this information.
So it's just like a virtualized like MPLS essentially. It's like
Pretty much.
Like a virtualized line that you're running.
Right. That's just right. It's like
You would do a trace route. It's going from one place to another. It's not going through a bunch of hops.
right.
Well, wouldn't the trace route always change because you're going through the deflects and the packets are constantly changing?
actually, if you run traceroute with
Sounds like
dispersive and you don't, if you don't turn transparency on and you run traceroute, you people won't be able to trace the traffic. We made sure that that's a security feature. So it's star. It will say ****. You can't trace it. You will never know where that's going. So
for whatever it's worth, the IP changes also from the gateway every time. It's not
the IP
static.
changes from the gateway.
Yeah, every time. So it's not static.
Hmm.
So,
like the actual gateway they have deployed in AWS, the public would change on that. Like it rotates on there.
correct.
How does
it do that?
Every time you renegotiate the connection, it spits out a new IP. We actually saw that yesterday.
yeah, because the instance when you
how does the gateway on the other side pick that up?
We route through the deflects. So every time like our software starts, so that's a security thing that you could add. So what Moody's describing is essentially an EC2. If you turn off an instance, right, like the IP when you boot it back up will change, right? So that's a setting that you can change. So you can actually change it to have the same IP. But for more security, actually that actually is a very nice security feature. on top of that is if you change the IP every time, what we do as a dispersive gateway is we punch out to our deflects because we know where our deflects are, right? And we talk to them and say, okay, give me a route to the gateway on the customer side. So the source IP can change, but we always know how to get to the gateway. Okay. And so, and that way, like, even if somebody was trying to trace, or trying to, get to, to him a gateway, they'd be like, why is this IP always different, right?
Right.
It'll never have
different side. And if we did an IPsec tunnel, this would not be possible because it would break the IPsec parameters.
Right.
Yeah. So if you're doing this between like Azure and AWS, or both are changing, the public IP addresses are changing, that's possible?
Yeah, like if you have a gateway on Azure and the customer gate and then the deflects are on AWS, that's fine, because as long as we register and we know the initial set of deflects, as long as we can contact the control plane with our proprietary artifact that we leave on the gateway, right? We can understand there's more deflects. We can understand if it's Azure, AWS, Oracle, wherever. We can understand that the deflect IPs are changing, not changing. So as long as we can communicate out to our control plane, we can change all the infrastructure in the middle every single time. So
yeah, so
interesting.
So check, and keep in mind, with whatever enclave or infrastructure we build, it will be on the cloud choice for them. So it will be Azure to Azure to Azure if they want it to be on Azure.
Yeah.
Right? We just validate on AWS, but same thing is expected on Azure. We know that's how it works on Azure. But check this out. So I've got this VM sitting in the finance, same subnet, same range. And this one, we use our dictionary naming convention, right? So it's called include. And just to confirm, if we come in here, same account, same AZ region, and go to include, you'll see that it's sitting on that subnet. So this would be their AVD or desktop for them, right? So you can see it's sitting on the 1105. That's the private IP for the machine. So, and obviously you could see in here, MP room, blah, 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 1368. I've got that VM running. It's Linux. You can see the name include blah, blah, blah. So if I SSH username BIOS to 10, 100, 100, 100, password, now I'm on that box in Tiani's home.
And this is the actual dispersive gateway there that's sitting at Tiani's.
Yeah, this is a private endpoint that's communicated to the dispersive gateway. This is the hospital's SQL server that they need for application A.
Yeah.
Right. So Tiani, what was the thing? There's a command you gave me that I can look up the location.
Yeah, you can do curl ipinfo.io. And unfortunately, you guys will all see kind of whereabouts where I live. So,
Sugar Hill,
Georgia. All right.
All right, noted.
Yeah. So don't come to Sugar Hill, man. So I'm not there. I promise.
We go to Sugar Hill. It's not for nothing malicious. It's for us to all get together and have some drinks.
Yeah, come down and have some drinks. That's all it is. So yeah. And so Moody, I can share my screen too.
Yeah. So look, guys, let's check this out too. And one thing, I'll stop sharing, but he's going to show you exactly the traffic that for the hub that I just made and going to the private endpoint. One thing, Tiana, I wanted to ask, maybe also for the Mindcore guys. So correct me if I'm wrong, someone from the customer side would also have access to this console, or is this for Mindcore? What we're looking at?
I think this would be just for us because we wouldn't have to make that many changes in here, right? Like, once this is kind of set.
Yeah, no, I completely agree. It's so how we work is we work off the service groups. So we would just do the initial configuration for the hospital and service groups. The only time you would need to come back in here is if something you need to add more things, right? Like, oh, do you want another service that or the hospital bought a new technology? You want the connection to that too? Sure, we can come back here. But this is the management console for Mindcore. So unless the hospital wants to manage this themselves. I mean, that's another story, right? But essentially, this is our GUI. We logged in here. This is the gateway that Moody is on, right? Starting his this is for the router gateway on the Tehama side, right, to route traffic to my side. And these are the services that we've configured, right? It's very simple. It's just an SSH service. So we're basically saying, hey, if you see anything addressed to 10.100.100.100, send it to us, right, on port 22. And you can change anything about this as well. You can have a different address, like you can have, other addresses that you can hide in plain sight, right? The actual network IP is never exposed, right? So you actually can hide, and you can just do different ports as well. So, and we often we offer, this is the transparency that I was talking about earlier. If you don't turn this on, you can never trace route this traffic. You will never know what it's going to. It's going to look really funny to trace route. It's not going to know where it's going to go. So, and then we have a lot of security features like encryption and stuff like that. You can turn it on and off. So you can essentially a la carte your services, essentially however you want it. However, the security controls that you want, all placed in one. So, and this is that gateway that oops. Not going to search that. This is the gateway that Moody is on, and I want to show you something really cool. So this is what we call our deflection cloud, right? And this is what you're actually the customers really pay for, is the managed attribution piece, right? So the gateway, the room gateway that Moody is on, is never talking directly to the customer. You have all these intermediate deflects in the middle that kind of essentially intermediately route your traffic. Some people can call it a proxy, if you will. So we're proxying through another node, right? And essentially you have many different nodes. So, and we always split the traffic 3 different ways. So even if you compromise one node, we'll roll over and self-heal to another node, right? And so you'll always be protected, and this is highly resilient. We follow the kind of space standard of triple redundancy. So we always have at least 3 links, and then we have 3 backup links. So it's even more secure. So you can even have more. If a customer really wants like 10 or 12, they can do that too. So this is the traffic that's actually flowing through right now into my house, and so this is why it's ultra secure, because even if an attacker at my house is seeing traffic from this IP or this deflex IP, he's going to have to piece together this IP as well as this IP. Oh, and by the way, they're going to change within like a couple minutes. So you're never going to get that much exposure. So that's why, Matt, I was talking about the attack surface being, kind of hard to aim for, because you don't really know what the attack surface is. He probably dropped off, but so that's what we have in terms of the integration. So,
and Colin, just Tiani, on that, when you were showing the port that we've got open for SSH, essentially our gateway can have, like, your gateway in our infrastructure can be open to this IP on 22 to Colin's earlier, and then lock it down 0 to the world.
Yeah, exactly. So only your machine, that your IP or your machine with the right key can have access, and then you can lock down everything else on that gateway, and then we'll take care of all the port abstractions and all that. So
right, and so it could not necessarily, correct me if I'm wrong, not necessarily as such. They may need to RDP to these and use them like jump boxes, and we can use, like, depends on the requirements, right?
Yeah, so you can add another service, client service. You can add the network IP that you're trying to get to, the ports, and then
for RDP, it's like 4 or whatever it is, right? So
what other intercept types do you have?
Yeah.
So we also have a ICMP service if you want to ping out and just prove connectivity. We have a gateway service that does CIDRs. So this is what probably we want to talk to you about, Colin, is how many networks do they have at the hospital? What type of CIDRs can we set up? Like, is it 10 networks, right? So we can set up a different service for each network that they want to protect and they want access to. And then we also have like the web service, which is essentially all your traffic is protected through dispersive, right? So that's another facet of the integration that we didn't explore yet. But one thing we could do is take all the traffic that Moody is sending through the Tehama router and protect it with dispersive, regardless of what service you're at. So you can send all your traffic out into the internet that's protected with dispersive. Right now, what it is it's only protecting this piece right here because that's the access because that's the access that you want for the customer. So it's very segmented, and you can segment it this way as well. So you would have but
So
all the
level
other,
3 on the ingress, how would that traffic hit the deflex?
I'm sorry, could you repeat that?
So like when you're doing level 3 traffic out to the web, like
Yeah.
you're just going straight to the web. So it's going from your gateway to the deflex to the web, I assume.
Yeah, exactly. Yep.
How does it do the reverse on that?
The reverse.
Does that go through the deflex, or does it straight just go to the gateway?
What do you mean by reverse?
Like the callback, right? Call?
Yeah. So the callback on it.
Going back, yeah. So going back, the gateway. So anything that is in this range that's intercepted by the gateway will also go back from the gateway to the deflex back out to the internet to the other gateway on the other side. So so you're always communicating with a deflect first, essentially. Even forward direction, you're communicating with a deflect. Backward direction, you're communicating with a deflect first, as long as it's dispersive traffic. So
okay.
Yeah.
Oh, because I get it.
Yeah.
Because if it's non-dispersive traffic, we won't pick it up, right? So that's why I was saying, like, if you to enhance this integration even further, you can have a web service gateway that picks up all your traffic, and that way, even if it's dispersive or non-dispersive, we're going to pick it up regardless and send it to a deflect before you access the internet. So, and we can localize your experience, right? If the hospital's in Baton Rouge, we can put deflects near Baton Rouge so that when they go outbound, it's very low latency. So all their connections are really fast, right? So
okay.
Yeah. And then
interesting.
And that's another thing, right, Colin? If there's a stuff that they don't want to go over dispersive and for whatever reason, right, and may have certain services that they want to allow outside of that private tunnel, then they could use our DNS filters. And
you just do like you either do that or you do a route filter or a route table.
Or a route table.
And you just route the traffic out
Yeah.
otherwise.
Yeah. But if they can't do it by IP, whatever, use the FQDN, and then that becomes allow only, and then there is traffic that goes through dispersive.
Interesting.
So if there's non-hosted workloads, let's say. Pretty cool, huh?
Okay.
Yeah.
Yeah. I'm excited. It's
Yeah,
a lot
so-
to get your mind around,
yeah,
but it starts making sense pretty quickly once you kind of have like a grasp.
Yeah. And like, obviously, like we'll do this in the Mindcore organization as well, as we progress, right? But that's kind of the idea behind it. Do you have they provided you, just on Baton Rouge, Colin, have they provided you like any network diagram or anything like that as of yet?
No network information just yet. I did have some kind of Visio. I have to find it. I might not have it. I do remember looking at it.
Okay.
But I don't
Yeah,
know.
like if you get your hands on it, just shoot it over to Yanni and I. That'll
Oh,
start.
100%.
Yeah, it'll paint an early picture to us. But you could see like it's a flexible, right? We just want to know how many networks we're talking, what are the workloads, where are they sitting?
Yeah, like what kind of like seed addresses
Right.
they have and whatnot.
What are the blocks?
Yeah.
yeah, because
Yeah,
we're
like
pretty
fine.
flexible
Anything
with
else
this
I can see,
topology. So yeah, sorry. Go ahead, Colin.
No, once I find it, I'll hand it over to you guys. What were you saying, Tiani?
Oh, I was saying, yeah, it's pretty flexible. This architecture, we can change it at will. So you can see that we can make a lot of different changes. We can change the topology. We can, add more gateways if needed, right? If, so we did talk about like HA mode as well. So we might, expand it to Azure and then do the HA mode there for the hospital, because I think that's something that they wanted. So, and we're
How would you
going to
handle the HA on that?
Yeah, so we have a thing called protection groups. So we would essentially, get Moody to probably use 2 of our Azure gateways in there. We put it in protection mode on Tehama side, and then we'll put 2 physical gateways also at the customer side, which we agreed to. So we'll have HA by hardware as well as HA logically, and that way, if anything goes down, we'll be completely, good for the traffic. So.
I assume just for the physical appliances, they just have a link between the two to detect whenever one goes down.
Yeah, exactly. So we actually different modes. There's like active standby. There's active. There's round robin, right? You can use one gateway and then you can use another gateway. You can trade off. So it also acts as a load balancer. So It depends on their network. So that's why I think the network's really important, Colin. So if they tell us, we've got 10 gigabits of stuff, and probably won't happen, but so we might want to consider like a load balancing setup. But if not, which probably the standard case for hospitals is probably just 1G connections. So
yeah, I think they're not running anything crazy from what I know.
Yeah.
This is great, guys. I apologize. I do need to drop, but Modi, Tiani, great job. Colin, Marcos, if you guys have any questions, they're your guys. So yeah, it was awesome.
Sounds good, Jason. Have a
Thank
great
you.
weekend.
Thank you. Appreciate it. Cheers.
Thanks, Jason.
Bye.
So
Yeah, so I
yeah,
have no other questions at this time. I mean, it's very interesting. It's cool. Like it's nice to see it working, like how intended.
yeah,
It kind of makes sense to me because like we used to do for our AWS private cloud, we used to kind of route everything out through like just a VGW instead of going to an IGW.
right.
So like when you're setting like a public versus a private subnet,
Yeah. Like the whole like do a tunnel and deploy an external gateway and do IPsec and all that. Like they won't like if we were talking about like just from a UX UI, customers don't need to even do anything on that. Like we can hide it completely with what we're doing there, right? So yeah, it's very
also
cool.
those kind of configurations, like this is the future that we're looking at right now.
Yeah.
This is going to be standard across the world,
And
I believe.
yeah, absolutely. And it's all quantum. It's all isolated. Like doesn't get better than that. But yeah, I'll send you guys obviously this is recorded, so just give it a bit of time to get processed, and then it will get attached to the meeting invite. So take a look. And I know Matt wanted to review it too, so that will be there. I'll send you the presentation. I'm gonna send it to you PowerPoint, so you guys, if you want to edit and adjust it as you're having market conversations, obviously hospital and beyond that, you can do that as well. And yeah, we'll wait. We're talking to Mick today, obviously, and Colin, kind of what you were saying too, right? Like December is December, right? And we don't, how that goes. Once it's the 15th, it's say goodbye to the remaining of the year.
It's over. It's
yeah,
over at that point.
Right,
So-
right after Thanksgiving, say goodbye to the rest of the year.
Yeah, you guys Thanksgiving and Black Friday and all that stuff, right? So we'll see how it goes, right? But we wanted to make sure this is in place and it's validated and it's good to give us all that confidence. And give the client that confidence too with the conversations that you're having. So I mean, it may mean the pilot kicks off in January, we'll see, but I mean, just we're there with you throughout the way. So
Sounds good. All right, so I think I think we have another meeting in 30 minutes, Modi?
yeah. I'm hijacking your calendars today.
Got to get some rest between these 30 minutes.
Yeah, actually I have an end user call. So.
Oh,
yeah, I'll be good. It's Friday, so I'm good. I'll be good. But yeah, I'll see you there. Thanks so much, Tiani. Thank you
Sounds
as
good.
always. Great job.
Thank you. Nice meeting you.
Thanks, guys.
Nice meeting you,
thanks,
Marco.
everyone.
Thanks. We'll
Thanks.
talk soon. Cheers.
Enjoy your weekend, Tiani.
You too, Colin. Thanks. Bye.
Take care.